Today class is transfer function of second order system. Today we will know about the transfer function of second order system. Previous class we will know about the first order system, transfer function of first order system. The second order system, the most general form of differential equation for second order system, may be expressed as the second order equation is 1 by omega n the square dy t by dt the square plus 2 zeta by omega n dy t by dt plus y within bracket t is equal to k x within bracket t, where omega n and k depend on the characteristics of the system, where omega n and k depend on the characteristics of the system under consideration the input function and output function or the input and output respectively omega n k and zeta are called the natural frequency steady state gain and damping ratio of the system The transfer function of the system described can be obtained by taking the Laplace transform on both sides. This is the transfer function of secondary system. This can be obtained by taking the Laplace transform both sides. This is this is the equation number 1. So the equation on taking a Laplace transform on both sides of the equation, with all initial conditions set is 0. with all initial condition set is 0, that is applying the Laplace transform on both sides. Applying the Laplace transform on both sides of equation 1 for L into 1 by omega n the square dy square yt by dt square by 2 zeta by omega n and t yt by dt plus yt is equal to L in bracket k x in bracket t. So that is the second order transfer function. The system here, the omega n is the natural frequency, k is the steady state gain, and zeta is the damping ratio of the system. Then the equation transformed by the Laplace transformation, then we will get the equation after Laplace transform. 1 by omega n the square is constant minus s square the capital Y capital S plus 2 zeta by omega n into S by S into capital S plus Y S is equal to k into capital X into S. It is the Laplace. It is the equation of second order system after Laplace transform. Here the d square y by dt square is the second order differential equation. Here the square, then the result is s square. Here the dyt by dt, therefore is s. Here the y functional of yt, the Laplace transform is capital Y into S is equal to k into capital X into S. This is the equation of second order system after Laplace transform. This is the equation of second order system after taking the Laplace transformation. It is the calculation of the second order system. Our target is from the equation to find out the output to input ratio. Here the y into s ys by xs is the output, it is the input, and there the output to the input ratio is it is the equation of second order system. It is also called the transfer function. The transfer function and their equation is this is the equation of second order system. Now Now I have taken an example of the electrical system for clear a confusion of second order system. Here this is a resistance, the inductor, there is a capacitor, and the T is a switch. Here the time is initial condition, the time is 0. We'll get the output voltage from capacitor. Here the input voltage is provided by the any power supply. So it is a circuit, electrical circuit can apply the KVL rule or Kirchhoff Ohm voltage law. Applying the KVL on this circuit. Here the input voltage is equal to R, is input voltage plus inductor voltage L di T by dt plus capacitive voltage 1 by C integration of 0 to T I T to dt. It is the equation of the circuit after applying a KVL. This is the equation number 1. This is the input voltage. The output voltage V0 T is equal to here the capacitive voltage 1 by C integration 0 to T I T into dt. This is the equation number 2. Applying a Laplace transform on the equation applying a Laplace transform, both side on the equation of 1. Then the equation we input here the input voltage R into I is plus L is constant di by dt for S. The current is I plus on by CS into IS. This is the equation after taking a Laplace transform. It is the input equation. The equation number second equation again applying the Laplace transform on the equation of both side. Here the IS is common, then the current IS is equal to V input voltage by R plus LS plus 1 by CS. This is the equation number 3. We will apply the Laplace transform on the outside voltage or output voltage. The equation, the output voltage, the equation is equal to 1 by C 0 to T and I and dt. The Laplace transform is Vs is equal to 1 by Cs into I is. This is the Laplace transform of output voltage. Here S is equal to Is by Cs. Therefore Is equal to V0 into Cs. It is the question number 4. Substituting the equation equation 3 and 4, then we get the transfer function. We get the transfer function. We get the transfer function, the V0 SCS is equal to VIS by R plus LS plus 1 by CS. This is the equation of transfer second order or transfer function, the ratio of output to input. Here the 1 by CS within bracket R plus LS plus 1 by CS. It is the transformation equation of second order system. And V output voltage by input voltage is equal to 1 by RCS plus LCS square plus 1. This equation, the denominator we can divide it by LC for compare to the second order transfer function system. So 1 by LC divided by S square plus R by L S plus 1 by LC. We know that the second order transformation equation is, it is the second order transformation equation is equal to X put by Y. Equation is output by input is equal to, the equation is K omega n square by S square plus 2 zeta omega n S plus omega n square. This is the second order transfer function and equation. We can compare to this equation. It is the equation of RLC circuit, and this equation we can compare to the second order system equation. Here the omega n square is equal to, this omega n can compare to the RLC circuit equation 1 by LC. Then we will get the equation omega n square is equal to 1 by LC. Here the omega n is equal to 1 by root over of LC. 2 zeta omega n. Here 2 zeta omega n to s is equal to this, compare to the r by l into s. The s, the both sides are r by l s. Then the equation will get omega n is equal to r by l, r by l. From the example, we may find that any second order system can be represented in the general transfer function as a model. So it is the equation of, say, transfer function of second order system, and it is the example of second order system. So we can find out the second order system from any electrical circuit or any RLC circuit.